Good morning, folks. We had a special video come out last night. Very different format. We've got space weather and Arctic air intrusion southward. Good bit of space science news here as we're starting with our star at spaceweathernews.com, and we find tiny wannabe bright active regions on the north and tiny dark patches of coronal holes on the south. We'll start there. One of the coronal holes delivered intensified solar wind yesterday. Density rises first, then a plateau of the particle counts. It brought us up from what was anemically slow solar wind to around normal solar wind speed. No concerns from the event, but in the KP index activity you see how sometimes it's not about the magnitude of the stream, it's about the change in telemetry, relatively. And speaking of those wannabe active regions, folks, this is pretty much what 2010 looked like on the Sun in the very early portion of cycle 24. Sunspots and solar flares were firing hard a year later, and that is coming. Quick little weather note as the extreme temperature swings are back. It's sub-freezing in many parts of Florida this morning, while the green color, which is above freezing, stretches up to Montana and actually into some patchy areas north of the Canadian border off the screen here. Again, currently warmer there than it is in Florida. Let's go next to a nitric oxide tracking study at the polar region. They are looking at chemical processes involving energetic particle precipitation affecting oxygen and nitrogen, and boy is this the place to do it. The mass in question is isolated by the vortex, and we have the most solar wind and Earth ion activity at the northern polar cusp, so the energy for the chemical reactions is there. Folks, it's a space weather and climate study based on atmospheric chemistry. It's just trying to hide as something else. And we're going to go back to that in a moment because first we're finding a star that has so much oxygen in it that the only explanation is that it's sitting inside a nova remnant with high metallicity. Actually, there's a crazy amount of carbon in this star as well, and while oxygen makes up our most important air-breathing molecule and is the most abundant element in Earth's crust, it has to be made by stars. And apart from their sparse solar wind plasma elemental abundances, the nova is how you get the big amounts of those elements. We're going back to stories that are covertly covering the solar forcing of the climate. Here we're studying magnetic flux tubes. This is how energetic particles stream along the interplanetary magnetic field from Sun to Earth, Earth to Sun, and to all the planets. More energetic than the solar wind protons, and they say that the initial system characterization is a breakdown of the magnetic energy in favor of electric current sheets. This has implications for material science, solar wind physics, galactic physics, and the primordial cosmic fields. And now we're really getting out there, because if the energetic aspect of the cosmos is the prince parading around as dark matter, then dust is the king. It's been well established that not only are dust estimates way off in terms of abundance, clumping, electrostatic character, and luminosity, they're also pulling a nifty trick at various size grains, electrostatic repulsion. Whether it's micron or nano-sized grains, they have the ability to stiff-arm each other and other charged material, preventing much of the agglomeration and larger dust particle creation that would be more easy for astronomers to understand. This plays at that large cosmic scale, the smaller galactic scale, and definitely in between, where we look at regions such as galaxy clusters, and now here outside of the individual galaxies, indeed the plasma takes on a much more important role than the dust. Instead of hiding luminous matter like dust, plasma's luminosity can be sneaky and misunderstood, and the turbulence of that plasma field has now been studied by suggesting it's analogous to a stratified atmosphere. This is indeed true in so much as we're looking at intracluster plasma stratified by plasma pressure, and stratified turbulence is not how they usually model the cosmic environments, and we learn here it makes a huge difference in the model's ability to reflect reality. Folks, all this dusty plasma discussion is the critical foundation of not just cosmology, but Earth's catastrophe cycle and solar forcing of the Earth's climate. If you're new here, try starting with our movies on those three topics, found right below the video. If you didn't catch the special video last night on the magnetic excursion ongoing on the planet, it is linked for you as well. We greatly appreciate your support. We've got wind map forecasts and shots of our star to close, and of course, we'll do this all again tomorrow. Right here, but right now it's 4:20 a.m. in the new Valley of the Sun. Eyes open, no fear. Be safe, everyone.